Alright guys, welcome to our channel. So if you're new, please subscribe for more tutorial video like this one. And this time, let's talk about integration by U substitution under integral calculus. So integration by U substitution is basically used when you try to integrate a function that the basic integration rules are cannot directly applied or used. So how do we try to integrate that function? So one of the ways is by using integration by U substitution. So here's how it works. So if we say that we have to integrate a function right here, f of x, and then the differential dx, so the first thing that we need to do is just to let u right here. We have to let u is equal to that function, which is this one. So this would be it, and then the second step is to derive the value of u. So that's why we have du over dx right there. Since our function is in terms of x, we need to derive it with respect to x. So du over dx would equal to be the derivative of that function. That's why we have f prime of x right here. And the third step is to find the value of dx. So the reason why we need to find the value of dx, because we have dx right here. So since we already have in the step 2, we can basically find the value of dx. So cross multiply, we have an imaginary over 1 right here. That would become dx multiplied by f prime of x. So that would be dx, let's say f prime of x is equal to du times 1. That would be du. So since we are trying to find the dx, we just need to divide both sides by the f prime of x, canceling this one. So that's the reason why we have here the value of dx in the third step. So since we already have the value of u and the value of dx, we can now substitute these to our original integration. So that would be, let's put equal sign right here, that is integration, and then since our function of x is just u, as what we can see right here, let's just substitute u right here, and then the value of dx is this one. So we just have to substitute this. We have du over f prime of x. So since all of this using integration by U substitution, f prime of x is basically a whole number, so we can factor that out through here. That's the reason why we have 1 over f prime of x, and then leaving behind this part of the simplified equation. So that would become the integration of u and then du. So right now we can easily evaluate this by using one of the basic integration rule, which is the power rule, or the other basic integration rule. So to understand the topic clearly, let's go to some of the examples. So here's some of the examples of the integration by U substitution. So let's answer number 1 directly. So let's say let's put number 1 or either solution right here. Let's put solutions and number 1. So in number 1, since we have the integration of the square root of 4 minus 5x, so we can find out that the function is 4 minus 5x. So we need to let u is equals to 4 minus 5x. And then the second step is to find the derivative of du with respect to x, since our differential right here is with respect to x. And then the differentiating the 4 minus 5x is we need to differentiate this each term. So the derivative of 4 is 0, and then the derivative of 5x is just 5. So therefore this just equals to du over dx is equals to negative 5. So we already have the second step. We need now to find the value of dx. So our dx, so let's put it this right here. So our dx is just dx. So since we need to cross multiply, dx a negative 5 and then equal to du multiplied by 1, that's just du, and then dividing both sides by negative 5. So therefore we are going to have dx is equals to negative du over 5. So since we already have the value of dx and we already have the value of u, right now we are going to substitute this to our original integration right here. So that's just equal to the integration of our function, or the u, and then the value of dx, which is this one, that would be negative du all over 5. So we can factor negative 1 over 5 right here, so through here, so that would become negative 1/5, and the integration of the square root of u du. So the square root of u is just equal to, say, negative 1/5, and then the integration of u raised to 1/2. So square root of u and then u raised to 1/2 are equal. And then let's put du right here. So right now we can evaluate this one using the power rule. So therefore that will become, let's put right here, that would become negative 1/5, and then u, since we have the exponent 1/2 right there, just add 1, that will become 3 over 2, and then all over 3 over 2, of course. And then since we already have integrate that one, let's put plus c, and then let's put it right here, negative 1/5, and then multiplied by u raised to 3 over 2. So since we are dividing right here in the term, let's put this upward, and when you try to put that up, it will become its reciprocal, and then never forget plus c. So we already have this one. We can simplify that even more further. We can basically factor this one and multiply it to negative 1/5. That would become negative 2, since 1 1 multiplied by 2, that is 2, and then 5 times 3, that is 15. And then our u, so going back here, we have already the value of u, which is this one. It's just directly substitute that. We have 4 minus 5x, and then raised to 3 over 2 plus c. So this would be our final answer for example number 1. So let's go to example number 2. Okay, example number 2. So let's put number 2 right here. So we have the integration of x squared multiplied by the function of 2x cubed minus 5 and raised to the third power, and then our differential, which is dx. So what is our u? Let's put let u is equal to, since this function is the in the inside function of the raised to the third power, we can let this u, and then if we try to derive this function, of course we are going to have a term that has a degree of 2, so that we can cancel this one. So let's see, to understand it even further, let's let u 2x cubed minus 5. So let's find the derivative. Du over dx is equals to, so deriving each term, that will the power rule. Let's bring down the exponent, that would be 3 times 2, that is 6x, and then minus 1 for the original exponent, that would become squared, and then the derivative of 5, which is constant, that is just 0, so that would be our derivative. So finding the value of dx, that's just equal to du over 6x squared. So let's just cross multiply this one. So since we already have the value of u and the value of dx, we can now substitute this through our original integration right here. So let's put equal sign. Let's put equal sign. Therefore we are going to have integration of x squared based on this number 2, and then 2x cubed minus 5 is just u, and then raised to the 3 power. Our dx is this one, that is du over 6x squared. So we can cancel x squared right here. Let's just cancel x squared. leaving behind du over 6, so we can factor out 1 over 6. That's 1 over 6, and then leaving behind the integration of u cubed and then du. So as we can see right here. So let's integrate this one using power rule. That would be 1 over 6, and then u, let's just add 1 right here since we are integrating. That would be 4 over 4 also, and then never forget plus c. So like we can just multiply this directly. That would be u raised to the 4, which is, we can substitute that also directly. So we have here the value of u, which is the original value of u, which is 2x cubed minus 5. So that would become 2x cubed minus 5 raised to 4, since this is raised to 4, and then over, we have 6 multiplied by 4, that would be 24, and then plus c. So therefore this would be our final answer for item number 3, or I mean for the example number 2. So that's it. You can pause the video and answer the number 3 and number 4 on your own, and let's just see how it works. So let's proceed answering number 3. We can erase number 1 since we already ran out of space. Let's delete this one. You can delete this one. So let's go to answering example number 3. So we have here integration of x cubed plus 2x raised to 4, and then multiplied by 6x squared plus 4, and then our differential dx. So what is our u? First step is let u. So in terms of finding the function or the u value, you need to find the function that has the highest degree. So since we have two functions right here, this one and this one, the highest degree is 3. Therefore, this is going to be our u value. So let u is equals to x cubed plus 2x. So that would be it. And then differentiating du over dx is equals to differentiating each term. We just have to bring down this one. That would be 3. And then minus 1, the original exponent, that would be squared. And then plus the difference, the derivative of 2x is just 2. So therefore, we are going to have the dx value. Let's put dx is equals to du all over 3x squared plus 2. Just cross multiply this one. So we already have the value of u and dx. Let's substitute this to the original integration form. Let's go to put equal right here. That would be the integration of, since the first function that we can see is the u value, that would it's just substitute u and then raised to 4. Our degree right here is 4, and then multiplied by the second function, which is 6x squared plus 4, and then our u is this one. That would be du all over 3x squared plus 2. So what function that we are going to cancel right here? So notice that if we try to factor out 2 in this function, we can now cancel the what we have here. We can now cancel this denominator. So let's see how it works. So if we try to find integration of u4, let's factor out 2. So that will become 3x squared and then plus 2. So that would be the factor, and then du over 3x squared plus 2. So we can now cancel this one and this one, leaving behind integration of u raised to 4 times 2 and then du. So since 2 is the whole number, we can factor that out through here, and then leaving behind u4 and then du. So we can now use power rule for this one. So let's continue to the integration of u raised to 4 du is just u and then plus 1. That would become 5 over 5, and then never forget plus c. you can put plus c whenever you already integrate a function. So therefore we are going to have we can put 2/5 right here, or you can use either way. And then let's substitute what is the value of u. So since we already have right here, we only just need to substitute that one. Let's put a parenthesis. Our value of u is x cubed, and then plus 2x, and then our power is 5 plus c. So this would be our final answer for example number 3 right here. So let's go proceed to example number 4. Example number 4 is the most difficult example for this topic. So let's go answering that. Let's say we have number 4 right here. So the integration of x plus 1 divided by the cube root of x squared plus 2x plus 1, and then our differential, which is dx. So let u, which is step 1. So since right here, since this is the function that has the highest degree, we can put that equal to u, which is right there, x squared plus 2x plus 1, and then derive that function. So deriving each term, that would become, bring down the 2, that would become 2x, and then minus 1, that would be 1, which is just 2x, and then plus the derivation of the 2x is just 2, and then derivation of 1 is 0 because this is constant. So therefore we are going to have dx, which is equals to du over 2x plus 2. So we already have the value of u and dx. We can now substitute this through the original integration right here. So let's put equal integration, and then x plus 1 copy, and then all over the cube root of our, since this function is our u, so let's just put u, and then our dx is du all over 2x plus 2. So let's put equal right here. So in order to cancel the numerator, we need to factor out 2 in this denominator. So let's do that. It would be x plus 1 all over the cube root of u, and then du over, we can factor out the 2, and then leaving behind x plus 1. Therefore we can now already cancel this 2. So leaving behind, since this is 1 over 2, we can factor that out. That would become 1 over 2, leaving behind the integration of 1 over the cube root of u, and of course du. So since this is in the cube root, we can change that into an exponent. 1 over 2 square root of 1 over u raised to 1/3. Since the cube root of u is equals to u, so we have here imaginary number 1, that would be our numerator for the exponent, and this 3 would become the denominator. Therefore the cube root of u is equals to u raised to 1/3, and then don't forget du. So simplifying even more further, we have u raised to 1/3 in the denominator. Basically we can raise that up. So when you try to raise the denominator with a exponent, just change the sign of the exponent. That would become 1/2 the integration of, since we're going to go put the denominator to denominator, or to, since we have to put the denominator to numerator, that would become u, and then change the sign of the exponent, that will become negative 1/3 du. So we can now evaluate this using the power rule. That would become 1/2, and then u, we have our exponent negative 1/3, so let's just add 1 to that. That would become u raised to the power of 2/3. That would be 2/3, and then of course this is 2/3, sorry, this is 2/3, and then divide, of course, that exponent 2/3, and then plus c. So we can simplify this. 1/2 and then we can raise this up. That would become the reciprocal, which means we are going to have u raised to 2/3, and then the reciprocal of the denominator, which is 3 over 2, since we have 2/3 the denominator, and then plus c. So we can basically factor this out through here and then multiplied it to 1/2. So let's put the solution right here, since we already ran out of space. That would become 1/2 multiplied by this 1/2 multiplied by 3 over 2. That would become 3 over 4. And then let's just directly substitute the value of u. Our u is in our original let u right here, sorry, which is this one. So our original u is x squared plus 2x plus 1, and then of course the exponent, which is 2/3 right here, to become 2/3, and then never forget plus c. So therefore this would be our final answer for example number 4. Let's box this one. So that's it, guys. Thank you for watching. I hope you learned something from this video and study well. And if you have some question, please comment down below and I will answer that right away. And thank you and God bless.